So we're looking at free fall. Free fall doesn't mean you're moving down necessarily. When I talk about an object in free fall, all I really mean is it's in the air. And it could be on its way up. We still call that free fall. Well, it's falling. Shouldn't it be moving down? In physics, what we mean by free fall is the only thing that's acting on it is gravity. Okay? I find the DFIC approach works good. Jana, as you get good, it's often around now where kids can sometimes go straight to the correct rewritten equation and numbers without doing all the intermediate steps. But in our notes, we'll be meticulous. So we read, a ball is thrown straight up with a velocity of 29 meters per second. How long does it take for the ball to reach its maximum height? Jana, I would say, what's this question asking me to find when it says how long? Time, not distance, just the way I'm reading it. I agree. So, well, let's go t equals question mark. What's that 29? Well, velocity? Initial or final? Okay. I need three things. That's only one thing. Boy. Oh, what's the acceleration? Not positive. Which way is it traveling when you throw it up in the air? Be obvious. It's traveling. I'm looking for a word that starts with letter U. Up. Is it speeding up or slowing down on the way up? So which way is it accelerating on the way up? Which way is it accelerating? If it's slowing down, it is still accelerating down. In fact, the entire time the projectile is in the air, A will always be, if we're near the Earth, negative 9.8. And I so rarely take you to the moon, it'll almost always be negative 9.8. Okay? I need to do more moon questions, though, because I dream, right? Well, that's two things. I need three things. So this question is asking us, how long does it take for the ball to reach its what? Maximum height. The top. Do I know anything at the top? I do. How fast is an object traveling at the very, very top for a split second? 0. I can say at the top, v final equals 0. If you want to, in your notes, you can make a little note at the top. You can even add for a split second, because it does come to a stop ever so briefly. And that I will no longer tell you. I will assume you've thrown objects in the air at least once in your life and maybe noticed this phenomenon. You played catch with yourself maybe at least once in your life, I hope. Okay, Jana, I'm coming back to you. Now I know three things. Which equation to find time? Oh, and you even got the t by itself. I figured you would. That's why I picked you. You got this stuff down pat. You get a little nerdy adrenaline rush from being able to do that all by yourself? Mummy, look what I can do. Time is always positive. If you ever get a negative time, don't just chuck the negative. That means you've made a mistake somewhere. Time is the scalar. It will always be positive. Everything else we're doing is vectors, and up will be positive and down will be negative. So I get 0 minus 29. I started to get nervous because the top was negative, and then I went, oh, no. I'm dividing by a negative acceleration. It's a negative divided by a negative. Brackets around the top. You get 2.9591. I'm going to write 2.96 seconds, but I'm going to store this on my calculator. So how long did it take the ball to get to the top? 2.96 seconds. Imagine it a little bit in your head. It would be slowing down the whole way, slowing down, and at the top it would, for a split second, come to a stop, and then it would start coming back down, speeding up. Yes? Next page. B. Oh, I should have said, I like it, question 3. I like everything here you're going to see in the future, I guarantee you. Karin, what's B want me to find? When I say maximum height, which of our physics concepts am I asking you to find? Time? Say no. Which one is maximum height going to be probably, folks? I heard somebody say it. Distance. Technically displacement, by the way. At the top, am I above us or below us? Be obvious. Am I expecting a positive displacement or a negative displacement? Here, I will get a positive displacement, unlike when we were dropping an object off of a cliff and ending up below from where we started. We got a negative displacement. So, Karin, let's write down D equals question mark. We've all just turned the page, but I'm pretty sure, if I'm not mistaken, VI was 0. No, thank you. 29. VF was 0. A, my pen's kicking in and out, was negative 9.8. Hey, Karin, I'm looking for an equation that has a D, a VI, a VF, and an A in it. There is one. I agree, it's VF squared equals VI squared plus 2AD. You feel up to getting the D by itself? That's a good start. What's going to go? I won't coach you. I'll coach you if I need to, but see if I can see you're pondering. VF what? Squared. Thank you. So start out. VF squared. VI squared. Wow. Okay, hang on a second here. Squared minus VI squared, and you said over 2D. You are correct, sir. I'm expecting a positive displacement. If I get a negative, I've got something wonky. Over 2A, not over 2D. Thank you. I got thrown off by my battery dying here. 0 squared minus 29 squared all over 2 times negative 9.8. 0 squared minus 29 squared all over 2 times negative 9.8. So I can tell you not only how long it's going to take to get to the top, I can tell you how it's going to go. Kind of nice. 42.9? Is that what you got as well, Karin? You're still typing? Sorry. Good. Okay. C. What's the impact velocity of the ball just before it hits the ground? What is it not? It's not 0. And I think I did my rant about if it was 0, you could do a belly flop onto the cement and it wouldn't hurt. It's 0 after it hits the ground. But the impact velocity, the V final, will not be 0. What is V final? Quinn, what is V final? Too slow. AJ, what is V final? What? 29. Why would it be 29? First of all, why is he technically wrong? You gave me the speed. What would the final velocity be? No. Why is he technically wrong with 29? He gave me the speed. What would the final velocity be? Okay. And I don't need to do any physics. I just need to realize that what goes up must come. If I'm starting and ending on the same height, this doesn't work from a cliff, but if I'm starting and ending on the ground, whatever speed it leaves, it's going to hit the ground with that speed again. So if you want to, you can make a little note, what goes up must come down. You can actually calculate it and you can prove it. And if you're bored, hit me up and I can walk you through it. No problem. But for what it's worth, I'm going to, again, Tito, pretend you played catch enough to notice, oh, it hit my hand at the same speed it left my hand. Especially because we're ignoring air resistance. With air resistance, there would be a tiny bit of variation. I went on my rant last day. Whenever we're in free fall, we're going to pretend air is not a thing to deal with. Everything is going to be a nice aerodynamic projectile with no air resistance. D. For how long is the ball in the air? Kyla, what's this question asking me to find? Didn't we find time with Jana already? Isn't the answer 2.96 seconds? Or is it what?
That's going up.
That's going up.
Thanks to the
Okay.
And then just gotta come back down.
So how could I figure out the total time? So there's two ways to do this. I'd like you to actually draw a little line down the middle of your page. If I had done Jana's question already, which we have, I could go time to top times 2. I deliberately kept it on my calculator screen even though I didn't store it. So I'm going to go 2.959183673 times 2. Or I could quickly recalculate it if I wanted to get it, use my answer button times 2. But that's 9 sig figs. That should be pretty good. And I could say 5.92. And if you do it that way, I'm perfectly okay with that. But I'm lazy. No, sorry, I'm organized. If I hadn't done Jana's question first, what if they just asked me how long the ball was in the air for, and I hadn't bothered figuring out t yet? I would go like this. I know A. I know VI. I know VF. AJ. What was VF? No, that's at the top. This is the total time, up and back down. You just told me the answer. What was VF? What? Negative 29. Right? And I could again use Jana's equation of T equals VF minus VI over A. It's going to be negative 29 minus another 29 divided by negative 9.8. This might be one of those situations, again, where if I had extra time on the test, I might do it both ways. Because if I get the same answer both ways, then I also know my answer from part A has to be right. That can't be a fluke. Type that in, and I think you also get 5.91836. We might be different maybe on the 7th or 8th decimal place, but I bet you will be bang on the first 4 or 5. Yes? You typed it in, Kyla? Okay. Sky typed it in already? No? Bracket, negative 29 minus 29 divided by negative 9.8. And, oh, there. That last 6 is actually a 7 because I used a rounded off value for the previous calculation. And we're at the stage now where you're going to find probably on a good half of the questions, there's more than one way to find it. I don't care which way you use. Pick. Usually on a test, I'll use the way that doesn't require me to use a previous answer. So I probably would have done the right-hand method on a test anyhow. Usually in my homework, I'll use whichever's laziest. Which I probably would have used your method, Curtis. 5.92 seconds. E. What's the displacement of the ball once it hits the ground? Your hint is it's a trick question. How high was it when it started? If we started on the ground, what was our initial height? 0? How high are we when we finished? If we started on the ground, what's our initial height? As a number, what would there wouldn't be any be as a number exactly, please? The displacement of this ball is 0. The vertical distance that it's traveled would be whatever the maximum height was times 2. That's the distance. That's the difference. That's probably the best example I can give you of the difference between a distance and a displacement. Technically, you went nowhere. Let's combine these two questions. First question, we stood on a cliff. This question, we threw something. Let's throw something from a cliff. So what we're imagining is that you're standing on the very edge of the cliff with your toes sticking out in midair, with your arm forward into open space, and you're throwing something straight up so that it can go up in the air and then come whooshing past your face, back down, and keep falling down, 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 down. So you don't need to worry about it hitting the cliff again. You okay with that? Okay. Ball is thrown straight up from a cliff at 12.5 meters a second, hits the ground at the base of the cliff after 8.85 seconds. William, what's A want me to find? I caught you zoning out, I know. Not my audience. What's a, how, what? Yeah. How high is the cliff? Which variable is height? Good. Technically a displacement. Are we ending up above or below from where we started here? I think below once it falls past us. Am I expecting a positive displacement or a negative displacement when I calculate this? Are we ending up above or negative? So am I going to freak out if I get a negative answer? No, I'm going to relax. All right? Let's write down D equals question mark. And, oh, that's a terrible question mark. This pen is dying. If I can get through today, that'll be good. Hey, what's that 12.5? VI? Positive or negative? Say positive. What if I threw it down instead of up? What would VI be? Negative. That's the only tweak. It would be negative 12.5. Okay, easy enough. So VI, 12.5. I think that's T is 8.85. That's only two things. I need three things. Oh, A. Negative 9.8. Again, even on the way up, it's accelerating down at negative 9.8. And then on the way down, it's accelerating down at negative 9.8. Which equation? Josh, which equation? That was my way of saying, I don't think he's looking at his sheet. He's zoning out. So, okay, it's on. Sorry, folks. It's how I teach. If you're zoning out, I'm on you. I apologize. Did you say VF? Do I know VF? Try again. And again, this is how I do these as well. I can't use anything with a VF in it because I don't know it. You spotted it.
VIT plus 1/2 AT squared.
And normally I would say get the D by itself, but lo and behold, it already is. And I'll just remind you now, because we've been casual with our notation, but in real life, Curtis, that's a vector. Negative and positive will make a difference. That's a vector. Negative and positive will make a difference. And that's a vector. Negative and positive will make a difference. Down negative 9.8. Okay? But now we're at the plug and chug stage. The nice thing is this equation will take into account the fact that you're throwing it up. In fact, this part right here takes into account its upward part. This part here takes into account its downward part. So it takes it all in for you quite nicely. It's going to be 12.5 times 8.85. You should, oh, how do I type 1/2 on my calculator? And I'm even too lazy to put 0.5. You should be able to type all this in one line without having to hit an equals in between or use your answer button. And that's how I prefer you try and type it. So can all of you try typing this on your calculator, please? 12.5 times 8.85 plus 0.5 times negative 9.8 times 8.85 all squared. I'll do it on mine as well. I use brackets to show multiplying when I handwrite, but Emily, I always use the times symbol to show multiplying on my calculator. It's way easier to read. Make sure you use a negative 9.8 and not a subtraction sign 9.8. You'll get a different answer. I have no idea what the answer. Oh, no. I have some idea. It's going to be negative. You told me yes, because we're ending up below from where. Okay. If I get a positive, I'll know I've messed up. You get negative 273 meters? Okay. Oh, and you know what? I think technically here I could go to 3 sig figs because of the 12.5 and the 8.85. I know negative 9.8 is 2 sig figs, but we're kind of going to ignore that for the purposes of our sig fig calculations. And again, since Kyla, it technically said how high. If you gave me your final answer as a positive, the cliff is 273 meters high. I'm okay with that, but I'm fine if you leave the negative in just to remind us we ended up below from where we started. B. What's the maximum height of the ball? What's this want me to find? Time? Say no. What would height want me to find, Elias? Which physics variable would height be? It's going to be a displacement again. Okay. Didn't we just find it? I don't know. Oh, you know what? We found how far below us it went. This is asking us how high above us it went. Are we above in part B or below us in part B? Am I expecting a positive displacement or a negative displacement? Okay, now we're going to have to be careful and ask which of the data they gave us can we use. Is VI still 12.5? Yeah. Is A still negative 9.8? Yeah. Is the time to the top 8.5 seconds? I can't use T. That's only two things. I need three. Oh, what do I know about being at the top? I don't know. I've never been at the top. Well, imagine, Karn, that you've had success for once in your... Never mind, that came out wrong. Pretend you're at the top. V at top is 0. Okay. Looking for an equation that has a D, a VI, an A, and a VF in it. There is one. Which equation, Curtis? Oh, he's getting the D by itself. And he remembered the squareds? You're starting to see why I said it's worth learning this method, because to try and memorize all these, and then all the special subcases when certain values are 0. Oh, and we've gone well beyond this. Sorry. We've gone well beyond that silly Science 10 trick that they give you. By the way, I would rather in Science 10 teach them formula manipulation, because it would also help you in your math classes. And when you wrap your brain around it, although it seems weird at first, it's pretty systematic. You're going to find, if you wrap your brain around this for most of the rest of the year, what I'll start to do is just give you one equation, and I'll say to you, okay, now anything is fair game. I can give you this backwards, forwards, from I don't care. Rewrite it. Okay, we're going to get 0 squared minus 12.5, don't forget the squared, all over 2 times negative 9.8. Is this a fraction? Brackets around the top. Is this a fraction? Brackets around the bottom. Got a positive answer, which is good. Anybody else get 7.97? Yeah? For a candy, can anybody tell me why this is the wrong answer? Because this is wrong. Why is this wrong? Why is the maximum height not 7.97? We're standing on a cliff and we measure heights from the ground. Emma, candy for you, my angel. You know what? I'm giving out the Halloween candies. So you get, oh yeah, we're going big or going home. You can have one if you want, or give it to a friend. Okay? Did you hear what she said? She said, that's only how high above us it went, 7.97 meters, but we're standing on a cliff, and we need to measure this from the ground. So, I've got D here for displacement. What would be a good letter to use for height? I use D for displacement. What would be a good letter to use for height? Thank you. H equals 7.97 plus 200. And now I'll make it a positive because we're measuring from the ground up. And I'm going to go 281. Of course I could. Meters above the ground. See the tiny little sneaky part? So if you're ever standing on a cliff and in the homework I ask you to find the maximum height, if you're getting the wrong answer, you probably forgot to include the cliff. C. What's the impact velocity of the ball when it hits the ground at the base of the cliff? Not 0. But what is this asking me to find? V what? Okay. VI was 12.5 A was negative 9.8. Can I use the time of 8.85 seconds here? Can I? Is this at the bottom, at the end of it? Is that what the time given? You know what? I can. Okay. Cool. Bonito. Amy, which equation? Oh, and the VF is already by itself, Mr. Dueck? Well, that's convenient. By the way, Amy, when we hit the ground, are we traveling upwards or downwards? Be obvious. Am I expecting a negative velocity or positive velocity here? I should get a negative. If I got a positive, I would get worried. 12.5 plus negative 9.8 times 8.85. Oh, I forgot the 12.5, Mr. Duke. That was dope. 12.5 plus negative 9.8 times 8.85. And I do get negative 74.23. I'll go negative 74.2. Good yawn, Quinn? Okay. Skip the baseball question because I saw Quinn yawning. We'll finish with example 6. Example 6 is tough. I like example 6. In fact, example 6 becomes very important in physics 12. So I'm setting the seed here. It says this: balls launched straight up from the edge of a cliff, 82-meter high cliff, with an initial velocity of 18 meters per second. How long until it hits the ground at the base of the cliff? Taylor, what's this question asking me to find? Okay. This question here is important because it's going to clarify a lot of the questions many of you have been asking me about all the homework we've been doing. So yeah, pick that up and bring your focus back. Absolutely. I would have dropped something in awe too because this is going to be really important. Karin, what's this asking me to find? Let's write down T equals question mark. What's that 18? What's the 18? VI? What's A? Negative 9.8. What's that 82? So what is the displacement? I'm going to give you a hint. It's not 82. This is the first curveball. D is not 82, and it can't be 82. So, this is a displacement. It just cares about our change in position. D is not 82. Quinn, say it. Just say the word you just said. I read your lips. Are we ending up above or below from where we started? So I'm telling you, the displacement is negative. We ended up below from where we started. That's the first mini curveball in this question. If you miss that, you might get an error on your calculator and it'll tell you that you've made a mistake because you'll have told the universe you're accelerating down but ended up above from where you started from. Okay. Which equation? D equals VIT. Don't write this down. Put your pencil down, Sky. The correct equation would be this. And we have solved for T with this equation before, but I told you a couple of days ago that the only way that we could solve this would be if either that or that, either VI or A, was 0. Are any of them 0? How would you get the T by itself? You cannot, because there's both a T and a T squared. Who are my grade 12s here? It's a quadratic, and you could use the quadratic formula. You would have to plus the D over to this side to make it equal to 0, and then that number would be A, that number would be B, and that number would be C. And you can do that if you want to, but here's the workaround. Pick your pencils up. Write that equation down, put a line through it, and say, can't solve yet. You will around Christmas time, but not yet. Pardon me? Yeah, you'll learn the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Or if you listened to my rant at the beginning of the year and you have a calculator with a built-in solver, you could actually, if you knew how to use the solver right now, solve this right now, but I'm not going to teach you that. Tito, how many things do I know? Count. I can find 5. Don't find time. What else can I find? What's missing? I'm looking for an equation that has a VF, a VI, an A, and a D in it. There is one. I need to get the VF by itself. It is not quite. How do I get rid of a squared? So you can, if you want to, cross out the squared and just put a big square root there. Oh, there we go. I'm back. Boy. VF equals the square root of 18 squared plus 2 times negative 9.8 times negative 82. (18 squared plus 2 times negative 9.8 times negative 82, square root answer button. You get 43.94, and because I'm going to use this, I'm going to carry extra sig figs because this is not my final answer. I'm probably going to go 43.9454. Is that what you got? Anybody else? I need to see some nods. No? I got a nod there from Taylor? I got it. So 43.9454, and that's wrong. For a candy, who can tell me why that must be wrong? Curtis, what? Which way are we traveling when we hit the ground? Here's the problem. In your head, what's the square root of 9? In your head, folks, what's the square root of 9? Because 3 times 3 is 9. But wait a minute. Negative 3 times negative 3 is also 9. The square root of 9 is 3 or negative 3. Your calculators will always assume you want the positive answer. They just will. And so when you're doing this question, you're going to have to realize, wait a minute, this time I don't want the positive 3 square root. I want the negative. And there is no way to tell that to your calculator except after the fact to add the negative. So you might want to make a note in your notes about that. The two tricky parts are catching that has to be negative and catching that this has to be negative. Curtis, good catch. You see why I said tricky? I can't really say it's tough because I haven't taught you anything new here. But it's tricky though. You really got to be paying attention to how the universe works. Okay. What were we trying to find? No. Time. And I think you have an equation that has a T, a VI, and A, and a VF. Jana, which one? I've come full circle because it's the one you started us out with. Wasn't that a nice symmetrical little lesson? Get the T by itself and you get to read it out again and you get your little nerdy adrenaline rush. What does time equal? T equals? Yep. Come on, that was pretty nice, Mr. Dueck, working that all the way back to the beginning. So negative, now I'm going to write negative 43.9454. I'm going to use my answer button. Minus 18 all over negative 9.8. Look up, everybody. Everybody look up. Bit of a problem because my answer button has a positive 43.94. So bracket because it's a fraction. Negative answer button. I'm just going to go negative answer. Minus 18 close bracket divided by negative 9.8. That's our workaround because we don't know the quadratic formula. This is why way back when, Emily, I said to you, if you know 3 things, you know 4. Actually, if you know 3 things, you technically can find all 5. This is one of the times where you have to find something. In order to find something, I would probably make this worth 3 marks or 4 marks on a test as a hint that you're going to need to find something in order to find something. That would be kind of your clue. But also, I think you would realize when you wrote d equals VIT plus a half AT squared and none of the t's canceled, I can't solve this. Try something else. Y'all get 6.32 seconds? Ta-da. That's most of the different situations I can throw at you. The only thing is in the homework, sometimes we'll be throwing an object down towards the ground, so VI won't be positive. It'll be, keep your eyes open when you're reading and pay attention, okay? But now you're starting to see why already last day I said we're going to pay a little more attention to our vector notation because we have to pay attention to direction here because we have a clear change in direction when we're throwing objects into the air. Speaking of Freefall, Mr. Dueck has the video. I showed you my Freefall video last day or 2 days ago. What's your homework? So this lesson went a bit shorter than I planned. You'll get some time to work on this, but I'm going to say to you, this is not homework for the weekend. I am trying to give you your long weekend next weekend because for you it's like a 4 or 5 day free. So we're going to kind of press pause on Tuesday and do a mini lab, but you're going to have a lot of homework between now and Tuesday. Number 1 is fair game. What was that, Quentin? I have no idea what you were saying. Anyways, I don't care enough to ask again. 2 is good. 3 is good. 4 is good. 5 is good. 6 is good. Are you going to sign all of them? No, I know there's at least one I'm going to skip. 7 is good. You can skip 8. 9 is good. The fact that it mentions Roberto Luongo tells you around what time that I created this worksheet. Yep, I crossed out 8. I'm going to say you can do 10, but cross out D. So 10 ABC. You can cross out 11. That was the one that I knew I was going to cross out. I don't like that baseball question. 12 is good. 13 is good. 14 is good. 15, 14? You can cross out 14. 15 is good. So here's your challenge question. I have not talked about number 16. I'm going to put a star next to it. That's my way of saying this is to see if you can have that aha moment. I'm going to challenge you with that one. But that one, if you remind me, I'll explain it next class if you're stuck. 17, 18, and 19. It's a lot, but short lab next class, and then the rest of the class is yours also to work on this too. Okay? We are basically done the unit. I finished Freefall. I finished my kinematics equations. You're not going to be learning anything new between now and your test. I'm just going to try and show you some clever ways where we use this. And I got more cool videos to show you, but not today.